On fundamental theorem of algebra and its context in terms of graphing polynomials. Now I use the fundamental theorem of algebra as kind of like an overall theme of this. We're kind of breaking down, we're taking different parts of it, and we're kind of really getting precise with it. And so I know that this screen looks a little jumbled. We got the definitions are in a way to help us, okay? So I have all these definitions, and I have up here I kind of talk about imaginary solutions in a very general term. We're going to kind of take baby steps towards imaginary numbers in the complex number system. And so one thing I want you to know is that it always comes in pairs. So imaginary solutions always come together. So in terms of 0, 2, 4, 6, 8, we can never have an odd number of imaginary solutions. And you'll see how that comes into play here, either in this video or a part 2 to this video. So over here I want to kind of mention all these definitions here. Now like I said or mentioned in class, these are very general definitions. These aren't definitions you'll necessarily find in a math book or the dictionary. These are kind of definitions that kind of give a broad spectrum of what they are. And so when I speak about the number of real solutions or roots, that requires the amount of times it crosses the x-axis, which we've been working with a lot when we tried to solve polynomials. We found that the solutions to those polynomials, or in the case quadratic equations, were x-intercepts, or where it crossed the x-axis. So when I talk about number of real solutions, we're referring to the number of times it crosses the x-axis. Critical points, this is a very general definition of critical points, is where the graph changes direction. So if I go from increasing to decreasing, or you see kind of a mountain or a valley, that point at which it changes direction is called a critical point. That definition is kind of, or that phrase kind of comes from calculus, in that the instantaneous rate of change at that specific point is 0. But don't worry, if you're planning on taking calculus, you can kind of get really familiar with that idea. But right now, and I'll kind of draw a couple examples here to help you with this. The leading coefficient. So if I describe the leading coefficient as positive, then the graph will finish by going up, which means from left to right, the last thing it'll do will be an arrow if it's positive pointing up, and if it is negative it'll be going down. And again, I'll be doing some examples here momentarily. And then of course we can label our critical points in a certain way. For example, we can describe them as relatively maximum minimum, in which the critical point, it is a critical point but not the lowest or highest critical point. Or then we have absolute maximum minimum, which is a critical point that is the highest or lowest. And no problem whatsoever can we ever have an absolute maximum and minimum. It's either or. I mean, it's either the absolute maximum or an absolute minimum. Or in some cases, we'll find out that some graphs have no absolute maximum minimums. And we're going to kind of lead into that here shortly. All right, so let's start out with the general problem. Let me see if I have a degree 3 polynomial, and the leading coefficient is, let's say, positive. Let me draw that in a different way here. Let's say blue. Okay, so this is positive. And the real solutions, let's say it has 3 real solutions. Imaginary solutions. Now this is important because we know it's a degree 3 polynomial. I've been kind of putting you guys in this situation a lot this year. That means there are 3 solutions. So if I have 3 solutions to give, and I've already specified that there are 3 real solutions, that means there would be 0 imaginary solutions. Okay, so let me graph this now. The leading coefficient is positive, so that means that it's going to finish going up in this direction. I don't know what's going to happen here, but I know the last thing it has to do is go up. All right, so I know it has to cross the x-intercept 3 times. So what I'm going to do, or the x-axis, so I'm going to draw 3 dots. I know my graph has to go through those at some point in time. Okay. So what I'm going to do is I'm going to draw this here. So it goes through here. In order to go through this one, in order to go through this one, we get this particular graph. That's a very bad looking graph there. Let me clean this up a little bit. All right, let me make that look a little bit better. All right, so there is a general degree 3 polynomial with a leading coefficient that is positive, has 3 real solutions, and there are 0 imaginary solutions. Okay, and so now we kind of talk about what is a relative maximum. Well, we have a relative maximum right here. Okay, it's a maximum point, but it is not the highest point. Okay, so that is a relative max. Okay. What about this guy? Here's a change in direction. This is a critical point. Okay, we're going to call that a relative minimum. Now, when you look at this graph, you might describe it as an absolute minimum, but notice how we're going forever in this direction. It is going to keep going this direction, so that's not the lowest point of this entire graph. So we would call that a relative minimum, and this would be a relative maximum. Okay, so there is one relative max, one relative min, and there are no absolute maximum or minimums. Now I want to make something very clear here. This is very, very important concept, is the number of critical points is related to the degree, okay? Whatever the degree is, let me draw this in different font here. The degree minus 1 gives me the number of critical points. Now this is bad organization here, critical points, all right? So if you notice the degree, there are 3, there's degree 3, minus 1 tells me there are 2 critical points, okay? So with that said, let's kind of clean this up a little bit. Let's say, for example, make my eraser a little smaller here. Okay. So let's start another problem, and I know I have another example right down here, okay? Oh, cool. All right, it's not going to erase my picture. That's good. All right. So now let's talk about another example that we might see here. Let's say, for example, I have a degree 4 polynomial. I'll change to black here. Degree 4 polynomial, let's say the leading coefficient is negative. Bad here. And how many real solutions? Let's say there's 4 real solutions. Let's not get into the imaginary quite yet, which means there are 0 imaginary solutions because I've already specified that the 4 possible solutions are real solutions. And let's take a look at this, all right? So let's say, all right, 1, 2, 3, 4. We know it has 3 critical points because a degree 4 minus 1 would be 3 critical points. And we know that it finished going negative. Okay, so I naturally, let me start out here. I'm going to go here. I have to go through here, and down. All right. Notice how I have 1. Let me calculate these. I have 1 critical point here, 1 critical point here, and 1 critical point here. There are 3. So I know I've satisfied the graph here, and let's start labeling these. Okay, this guy is an absolute, or no, oops, sorry, relative minimum, because it is a low point, but it's not the lowest point. This guy is a relative maximum. All right, and this particular point, it is a relative maximum. It's a maximum, but this makes this is a more precise one. This is called an absolute maximum, meaning that is the highest point that this graph will ever get is right here. Okay, and I know our graphs will be different because we're kind of just doing abstract kind of drawing, so your absolute maximum might be somewhere else. But know that at some point in time you're going to have the highest point in this because it is an even degree function, which we'll kind of talk about as well. So the relative number of relative maximums are there are two maximums. There's 1 relative minimum, and then we clarified one of them as a absolute maximum. Okay, and I know it's kind of odd because I describe this as an absolute maximum, but I'm describing it also as a relative maximum. But what we can do is we just kind of describe how many maximums there are, how many minimums there are, and then if there is an absolute maximum, we document that. Okay. So, all right, let's try something here. And I'm going to leave you kind of with this to think about. I'm going to make a part 2 video of this. But let's say I have a degree 5 polynomial. Degree 5 polynomial. Leading coefficient is, let's say, positive. Okay, so we know it's going to go up when it finishes up. Let's say I only have 3 real solutions, meaning it only crosses the x-axis 1, 2, 3. Okay, so I know that imaginary solutions have to come in pairs, so that would probably make this have 2, let's make this in blue, 2 imaginary solutions. They have to come in pairs. If I said that I had 4 real solutions and that would make 1 imaginary, that wouldn't work. And we'll kind of do investigations into that. So let's say, for example, all right, I know I have to cross this thing 3 times. All right, now think about it. I have 2 I have 2 critical points, and I know that I have to have 4 critical points based on the idea that there has to be one less than what the degree is. So think about how I'm going to complete this. Aha, look at that. So I created another 2 critical points, but I did not cross the x-axis, and this is where imaginary solutions exist, people. Okay, so this is going to be our investigation here. So I'm going to leave it at that. There is one more thing I wanted to hit here, and that's the idea of let's document these. I have here is a maximum. This is a maximum point, not the highest point. Here is a maximum point. So I have 2 maximum points. Do I have any absolute maximums? That question, the answer to that question is no, because you'll notice that this goes on forever. So there's high points all the way up here that these guys aren't the highest peak. What about relative minimums? I have a relative minimum right here and right here. So that's 2 relative minimums. But do I have any absolute minimums? I do not, because you'll notice that this goes on forever in this direction. And so we have 0 absolute maximum or minimums. So that concludes this video. This is just an intro video, kind of what we've been talking about the last couple days. And I'll make another video to supplement this as we kind of dive more into this, okay? So have a great evening, and I'll see you guys all later.